Tata. Okay. In this topic, we will understand a little more about checkpointing, how it works, and how it can have an impact on performance of a database. You can see here, I have depicted transactions have been happening, and from time to time they have been written down into the reader log file. Whenever a commit occurs, for sure log writer will write, but whenever the redo buffer gets full or every 3 seconds, log writer will anyway write. Now what I have also marked here are 3 red lines. Now these 3 red lines are points at which a checkpoint has occurred. What happens during a checkpoint? Whenever the checkpoint process gets initiated, it will flush down the contents of the redo buffer, flush down all buffer cache entries into the data files. It will make entries only of the dirty buffers, and it ensures that all the files are synced, and basically it is going to ensure that the file headers have the same checkpoint number. That ensures that the files are in sync as of that point in time. Normally, during a proper shutdown, the checkpoint is the last task that would occur, which will ensure the last entry in the redo log file is a checkpoint number, and all the file headers also have the same number, which means the database files are in sync and it can open normally. In case a checkpoint does not exist in the redo log file as the last entry during startup, it will have to perform recovery, and the way it will do recovery is to read from the last checkpoint all the entries and do the recovery. Now the question that we have is, if we have a situation like this, and right now all these entries have been written, and if the instance crashes, we have to recover by applying all these entries when recovery occurs. How can I make the recovery be faster? If the checkpoint had occurred here, then I would have had only so many entries to recover. So the concept that we need to understand here is, how do I control the frequency of checkpoints? And by controlling the frequency of checkpoints, I can control the amount of data that is to be recovered during an instance recovery. And by controlling the amount of data that is to be recovered during instance recovery, we will hasten or slow down the process of instance recovery. So over here, how do you think we can control this as such? There were parameters prior which said how much data will be written to the redo log file on which a checkpoint would occur. That was one parameter. The second parameter is every so many seconds a checkpoint is being forced. Both the options do not control how much time it will take to recover the database. All that we are forcing is how frequently the checkpointing is occurring, but by controlling the frequency of checkpoints, it is not necessary that we will control the amount of time it takes to perform instance recovery. For this purpose, Oracle introduced a parameter called fast start MTTR target. MTTR means mean time to recover, and you can specify a time in seconds. By specifying this value in seconds, what you are instructing the instance is, whatever be the number of transactions that are occurring, whatever be the frequency of commits that are occurring, at any given time, in case there is an instance crash, please recover the instance in so many seconds. For example, if you say 300, then the checkpointing frequency is automatically regulated by the instance to ensure that the instance can come up for sure in 300 seconds. So we do not specify how often in terms of time or how often in terms of amount of transactions. We specify directly what is the time that the instance can take to recover. So if I set this value to a larger value, let's say I set it to 1000, then the checkpointing will become less frequent. If I set this value to a smaller value, then this will ensure checkpointing becomes more aggressive. The benefit of the checkpointing becoming more aggressive will be more I/O will keep happening because DB writer will keep writing more constantly, but that will impact performance as this instance is running. But when the instance crashes, it will recover for sure within 200 seconds. On the other hand, If I have a larger value, the frequency of checkpoint will reduce, hence the amount of I/O done will be reduced, but the problem would be is in case an instance crashes, it will take more time to recover. So that is the impact of fast start MTTR target. And finally, what value you set for MTTR target will depend on what is the time business says is required to recover the database, and accordingly you will set it, and you now know what is the benefit or disadvantage of setting this value. So this is how a checkpointing works, and this is the impact of fast start MTTR target, which will surely have an impact on performance or an impact on recovery.